Hello, everybody. So in this video, we are going to start the problems that we want to practice in order to get used to the mass balance equation and to know how to apply this mass balance equation on different cases or different problems. So in this problem here, we have 1,000 kilograms per hour of a mixture of benzene and toluene that contains 50% benzene by mass, um, and it's fed to a distillation column to be separated into two fractions. The mass flow rate of benzene in the top stream is given, and the toluene, the bottom stream, is given, and the operation is at steady state. We want to write the balance equations on benzene and toluene to calculate the unknown components or component flow rates in the output streams. So the problem this way is not going to be clear, and the inputs that we have are not very clear. So one thing that we do that makes things much easier is to draw a diagram and put all the givens on this diagram. This saves a lot of time and reduces the possibility of using an information in a wrong way, and makes it easy for us to visually understand what's going on here. So the flow diagram that we have here contains the feed. Again, I'm going to go through the given. So 1,000 kilograms per hour of a mixture of benzene and toluene contains 50% benzene by mass. So I have 500 kilograms per hour benzene, and the rest is toluene. And the mass flow rate of benzene in the top stream is 450 kilograms per hour. So this is the mass flow rate of benzene at the top stream. And what I know that there is 475 kilograms per hour of toluene in the bottom stream. And we know the operation is at steady state. Of course, there is toluene here and there is benzene here, but we don't know how much because it's not mentioned. And this is what we want to calculate. So now the problem is much clearer. It's easier to know what's going in and what's going out, and what are the information that we know and what are the information that we don't. One thing else that is very important, or it's very helpful to do when we go through the or we solve such problems, is to number the streams. So I have this stream to be stream number 1, this stream number 2, this stream number 3. This is very helpful if especially if we have large flow sheets. We might have 30, 40, 50 streams. So numbering the streams makes it easy for you to tell which stream you are talking about, or which stream that you are interested in. So the what we're going to do now is to draw, as it's mentioned in the problem statement, to draw the balance equations on benzene and toluene to calculate the missing information. The missing information would be the toluene here and the benzene here. So first we need to define the control volume, which is the distillation column, and to see what is the shape of the equation that we are going to use. So this is steady state. We have no reaction. It's a physical system. So the equation will end up to be the summation of input minus the summation of output is 0. And the rest is just to substitute. So we are going to apply the equation on benzene, which is the benzene in the feed. It's 500 kilograms per hour equal 450 plus the benzene here, which we don't know. So I say B1, which is B benzene in stream number 1, or the mass flow rate of benzene is stream 1. B2 is the mass flow rate of benzene in 2, and mass flow rate of benzene in 3. This is 500, this is 450, so we can calculate the benzene in stream 3 to be 50 kilograms per hour. Same for toluene, we can apply the same thing. It's 500 equals the toluene here that we don't know, plus 475, so toluene here is 25 kilograms per hour. We said in the beginning that we can apply this equation on one component or more than one component. So I can apply this on the total stream. I can apply this to stream 1, stream 2, and stream 3. So if you apply this to stream 1 and stream, of course, now everything is calculated, but it's now done as a check. So B1 plus T1, which is 1000, the feed that we know, equals the benzene 2 plus toluene 2 equals plus benzene 3 plus toluene 3, which would be the left-hand side and right-hand side are equal to each other. So it's kind of check that we can do. So this problem is a very simple problem, but it actually is important because of more than one reason. So the first reason is we're now able to use the equation, substitute, and calculate things, which is a very important thing. This is what we are going to be doing until the rest of the course. We knew that we have to draw a diagram and put all the information on it, so this makes the dealing with the problem much easier. The last thing here is that we knew that we need only two equations to fully do the balance of all the components that we have. And I have here benzene and toluene. We use two equations to solve all the variables that, or to calculate all the missing variables. We have one extra equation, which is the total balance, but the total was dependent on the previous two equations. So if you add equation of benzene to equation of toluene, it's going to give you the total mass balance. So in general, and we are going to mention this in details later, the number of equations that we write is equal to the number of components. So I have here two components, so I have to write only two equations. The third equation is a dependent equation that's not adding anything new regarding the calculation of the missing parameters. The second example is about a batch process, and in this case we have methanol water, two methanol water mixtures. The first mixture, we know the methanol is 40% by weight, the second methanol is 70% by weight, and the mass of the first mixture is 200 grams. And we mix it with 150 grams of the second mixture, and we want to find the composition and the mass of the product. Again, this is a problem that includes a lot of information, a lot of data, so we have to draw it. So we have a feed stream which is 200 grams, which is the first mixture containing 40% methanol. The weight percent and mass percent are the same, so it's 40% methanol by mass or by weight, and the rest is water. The second is 150, and it contains 70% methanol by mass, and the rest is water. And we have the product that I don't know anything about. I just know its mass flow rate is M3, and I know it contains water and methanol, because there is nothing happening here, no reactions and nothing taking place. I named this 1, 2, and 3. It's not named explicitly, but I said this is M1, this is M2, and this is M3, so I know that these are the numbers of the streams. So again, in this process, we have feed in, we have product, we have no reaction, it's just a mixing unit, and we have no separation, and accumulation. So in this case, we can have the equation reducing to input equals output, or input minus output equals 0, and we can apply it to methanol and water. So for methanol, the methanol in, it is equal to 0.4, which is 40% multiplied by 200 plus 0.7 times 150. This is the methanol in, and we have methanol out that we don't know till now. Now and then we have we can calculate the methanol in the product as flow rate, which is 185 grams. The same for water. It's going to be 0.6 multiplied by 200 plus 0.3 times 150 equals water in stream 3. So I can calculate water in stream 3. And from these we can calculate the total mass, or you can do this by total mass balance. It's going to be either way. It's kind of repeated information or repeated equation. So the total is going to be 350 grams, which is the addition of these two guys, okay, or M1 plus M2, okay. Now I got the amount as a flow rate. Of course, this is gram. I forgot to add the gram here, but this is gram. And for the composition, we can simply calculate the composition as mass percent by dividing each mass by the total mass. So this is 185 over 35 and 165 over 350. I'm sorry, 165 over 360. Now we get the mass percent or weight percent of each of the two components in the final product stream. So this is another example. It's very similar to the previous. It's good for practice. There is one more example, which is going to be a little tricky because it contains more details that we don't have here. So we will cover this in the next video, inshallah. So I'll see you then.